Hey, what's up guys? It's Pedro here from noobcoder.com, and in this tutorial we're going to be talking about removing the first node within our linked list. So to get started, you can see that we have our linked list, that there are 4 nodes within it. Our header is pointing to the first node, and our tail is pointing to the last node. Now there are 2 test cases that we should account for. One is if the list is empty, and 2 if the list is not empty. Now the first case is pretty simplistic. If the list is empty, we're not going to do anything, essentially. So I'm just going to move on to the second case. Alright, so let's think of this logically, how we can remove the first node from our linked list. We have our header that's already pointing to the first node, but we want to get rid of this node. And you know, since header is pointing to this node, we have access to data, and we have access to the pointer, which points to this node. So you might be saying, well, I could just say header is equal to header arrow next, right? And that would give us the following. But what this doesn't account for is that we dynamically created this node. That means it's allocating memory. So whenever we use the new keyword, we have to be careful. We have to delete this node to free up the memory. So we just can't say header is equal to header arrow next. But if I advance header here, I no longer have a pointer to the previous first node anymore. So there's no way for me to delete it. So let's take a look at another example. In order to remedy that, what we can do is actually create a temporary pointer. Now this temporary pointer is going to point to what header is pointing to. Then what we can do is advance our header pointer. The next step, let's delete the node. And last but not least, from here, all we have to do is decrement the size. So now let's actually take a look at the C++ code. Alright, so from here you can see that we have our remove first method. It doesn't return anything and it takes in no parameters. So we have 2 cases, case 1 and case 2, the empty list and the not empty list. So we said the empty list that we're not going to do anything. So we can actually write a clever if statement. So instead of saying if the header is equal to null to test if the list is empty, what we can do is actually skip all that and make it so that this code only executes when case 2 is true. So in order to do that, I'm just going to say if header does not equal to null, that means we know that it's not an empty list. Execute this code. So when you call the remove first method on an empty list, it'll check to see if this condition is true. And since it's going to evaluate the false, nothing will happen. So now let's actually code our if statement. So the first thing we said we need to do is actually point to whatever the header is pointing to. And we're going to create a temporary pointer to do so. So I'm just going to say node star temp is going to point to the header. The next step is to actually advance what header is pointing to advance it to point to the next node. So I'm just going to say header is going to point to header arrow next. Now, remember what we said, I have to delete the previous first node. So I'm just going to say delete temp. And last but not least, we're going to decrement the size. Alright, so now let's head over to our main method and let's actually test this out. So here we can see that we have our linked list. We're appending 1, 2, 3, and then we prepend 10, and then we just print it out. So 10 should be our first node. So I'm just going to say list.remove first. Then I'm going to print out our linked list one more time. So now I'm just going to bring up the console. I'm going to close this out. I'm going to compile our file. Now let's execute it. And because I didn't save, so let's actually save the file and then compile it. And you can see that we get a printout 10, 1, 2, 3. We called the remove first method. And now we have a linked list of 1, 2, and 3. So that sums it up for our removed first method.